Good afternoon, everyone. Today we are going to start our session. Okay, but participation is very low, so we can wait for next another 2 minutes. Okay, so then we start the program. Thank you.
Hello everyone. So sorry to join late due to some network issue. So I think we have only around 6 people today. So let's do one thing. Hello Bhaskar sir. So why don't we just go ahead and start? Okay, and then we'll take it further from there.
Okay, hello everyone. Uh, I'm Bhaskar Banerjee. So today we are going to talk about emerging technologies like blockchain, artificial intelligence, and machine learning, and also Internet of Things. Let me share my screen first. think is visible. Okay, so these technologies like blockchain, artificial intelligence, machine learning, and kind of things, they have emerged in little over a decade, but they're making a paradigm shift to our society in terms of commerce, economy, and social aspect. These technologies, few are very broad, like artificial intelligence and machine learning is a very, very vast technology. And naturally, its penetration is much higher than any other emerging technologies. But the other technologies like blockchain or IoT is nowhere any less complex. Maybe they are not as broad as AI or ML if it goes to the application level, but still they are pretty much complex and uh, they have very much uh, complex and wide applicability in our modern life in when where the technologies goes into improving the lives, the business, governance, and social sectors. Let's start with blockchain. So since we'll be doing very brief discussion about these technologies because the technology, all this technology we are trying to cover today, it's one itself is large enough to not to be covered in an entire. So we'll be just scratching the surface basically today. So for blockchain, we'll be covering these five topics. First, we'll see what is blockchain, and next we'll see how blockchain works. Then when to use blockchain and a different type of blockchain, and then the use cases will more or less follow the same pattern for other technologies we are going to speak about today. First, what is blockchain? Blockchain is a distributed ledger technology, what we call DLT in short. Distributed ledger technology is a technology where the ledger, where the data is stored, is distributed among different nodes, and that is the key point of other features or other properties of blockchain. Second comes the immutable data storage. Because of it's a DLT, it's gives the immutability to the data storage. So the data is not mutable. You cannot change the data. Once the data goes into the ledger, it cannot be altered. It can blockchain is one DLT. I mean, there's different kind of DLTs other than blockchain, but they commonly share the same aspect that their data is immutable. Third is a trustless system. Trustless system is a very unique approach or unique feature which gives more power to the users, the consumers, and um, the other developers and everyone. So what is trustless system? Basically, when we are using a system which is centralized, like let's say think about Google or Facebook, they are basically storing the data in their servers. Maybe it's distributed among different servers, but they're the central authority. They are keeping all the data in one place. So we are basically trusting them that the data will be safe, the data won't be altered, the data won't be changed. So the entire trust of all the users is coming into one central point. Where in distributed ledger technology, the system is trustless. So basically, there is no central authority to trust. There is no trust factor. Everything is tied together, so the entire system rolls automatically without keeping trust on anything or anyone or any system. And fourth point is the transparency. By default, if it's not configured other way, then blockchain gives the transparency of entire system. So all the transactions will be open. Everything can be tracked. Everything can be monitored, keeping the anonymity, obviously. Uh, so that's how the blockchain is developed. So next we'll cover how blockchain works. Distributed this DLT technology is distributed ledger technology, but it's not like distributed computing. How it is different? Like in distributed computing, let's consider a render farm for that instance. So when we need to execute a job, when we need to execute a process, we send the process, and the same process gets broken into different parts, and each part is distributed among different computing nodes. And then the entire all the nodes, they process their associated, allocated process, and they return it back. Where the DLT, we have the same copy of exactly same ledger distributed among different nodes. So basically, they are not getting the fragmented part of the ledger, but they are getting the entire ledger among different nodes. And there comes the main part, the security, immutability, everything comes there because all the nodes are having the exactly same copy of the same ledger. So if one node try to manipulate it, or if one node try to rewrite the entire blockchain, or if one node try to alter anything, then other nodes will not come into general consensus, and it will reject the effort. I mean, maybe a new transaction, maybe it's an attempt to try to rewrite the entire blockchain. So whatever one node will try to do, if other node doesn't come into general consensus, it will be rejected. And that's how the distributed ledger is defined from distributed computing. Let's see a little bit with the illustration how it works. Basically, when blockchain, the distributed ledger, is created, the first block created, which is called the Genesis block. So first block is created with an algorithm, and then each block will be having a hash. That is maybe many of you very familiar with hashing, where to validate the data. Like when we check the integrity of a file, we do the MD5 of a file. So it takes the entire data of the file, and it MD5s and gives you the MD5 string. So any a single byte change in that file gives you the different MD5. That's how we check the integrity of the file. Exactly same way, the entire block is hashed, and that hash gives the unique hash, which is associated with the data of that block. So is any change, any a single byte change in that block will give you the different hash. And so you can see the hash from this block 0, which we call, which we may consider as the Genesis block, is coming into the header of the block 1. And then the block 1 is having all the transactions. And when the enter block is filled with the transaction, then the next block is created. And next block, the block 2, is having the hash of the enter block 1's data as a header. And that's how the entire block is created, and that's how it's called, that's why it's called blockchain, because it's chain link. The one block is having the link to the previous block by the hash of the previous block's entered data. Now, if we consider the monetary transaction, like a cryptocurrency, Bitcoin, or so, which is very common, and which will illustrate very easy how the blockchain works technically. So, if a transaction starts, now A transacts with B. Now, transaction initiates, and A sends a certain amount of money to B. Now, blockchain, the transaction is initiated in blockchain, and it has been broadcasted among all the participating nodes in the blockchain. All this node will start now verifying whether this transaction is valid or not. How it will validate? It will first check the address of the participant A, whether that address is having enough balance or not. If it's having enough balance, then it will try to push that data to block. Now, when it will try to validate this, it will go to its the block, the previous block where the transaction was happened. I mean, A is having the balance, and then it will validate the hash, and it will push the same transaction to the next block. When the enter block is formed, then it will try to write into the blockchain, and there it will come the general consensus, where all other participating node will validate all the transaction. It will check with the previous block, and it will also, when the new block is creating, it will check whether the uh, the hash of the previous block is matching or not. If everything match, all the participating node come to a general consensus. There is no integrity issue with the data. Then it has been broadcasted as a successful transaction, and the block will be returned into the blockchain. And once this is written and all the transaction, so we have to keep in mind that one block doesn't consist of one transaction. One block consists of multiple transactions. So when the block will be written at one time, all the transactions that will be written in that block will be passed through. So when the block is written in the blockchain, we will get the money. And along with the other transaction which will be waiting to be written in that block will be passed as well. Now it comes when to use blockchain. Is very common in technology world. When a new technology comes in, people just jump into the technology and they want to be, jump into the bandwagon and be part of the technology. They want to reap the benefit out of it because new technology, people will be more interested. But we have to keep in mind each and every technology has their own applications and use cases. Each and every technology cannot cater to each and every needs of our human society. So, like every other technology, blockchain has certain use cases, and in certain cases, blockchain cannot be used. It can be used, but it's not useful. I mean, it won't. In certain cases, it won't give any more benefit than any other technology, competing technology, or maybe in certain cases it would be even it would be even I mean not so good to use it because any counterpart technology will be giving more advantage than using the blockchain. So when to use blockchain as a technological company or as a startup or as an innovator, when we try to use a blockchain or when we think about suggesting a solution to our client to use blockchain, when should you use it? First thing, any of these criteria which I have written can satisfy. If any of the criteria satisfies, then it's a good use case of blockchain. So when the data immutability is important, let's take an example. If you see in India in the real estate, not real estate in the sense of real estate, but the land. If you take the land, then the data mutability is a big part because we have seen a lot of time and in history and even present days that there's a fake registration certificates and all, and people are taking advantage of it. There's a lots of double selling of same property and such things. So the problem lies because even if in many part days it is computerized and it is computerized, digitized, and everything brought into the digital version, but still this counterfeit certificates and counterfeit registrations are happening because still we are relying on a trust-based system. We are relying on a system where everything is centralized. It's not decentralized, and the data is not immutable. So here, this is a very good use case for blockchain because the data immutability is very much required. Now, when we are going today to buy a piece of land, then we cannot just simply rely on the registration paper or whatever has been issued by government or anything, because it can be altered, it can be changed, it can be made counterfeit. So we have to go through a long process of validating that those data. But when we will bring this to the blockchain, then this process will be validation of a matter of second. If you go to blockchain, if you see, okay, the A is the owner, then there's no scope or there is no question about validating further, because the blockchain itself is giving the immutable data, which is by default is a completely transparent and secure data. So we can be very sure that this data is accurate and there is no integrity issue with this data. So when the data immutability is very much important, we can definitely use blockchain. Second, when there is a need of a trustless system. Beyond this land, if we think that the voting system. So in voting system, we need a completely trustless system, because when we are voting, the voting could be for anything, but when we are voting, we need a system where we do not trust anyone. When we are putting something, when we are giving our vote, the vote should be registered accurately without anyone's authority. Because when we are putting through any authority the vote, that means we are putting on trust. And when there is a point of trust, there is also comes the point of breaching the trust. So the breaching of trust means that's the alteration of the system. So when we need a system where there is no scope of alteration, then we need blockchain, because then it will provide the trustless system. It will be completely automated one. There will be no central authority, or there will be no point where we'll be putting trust. Who will be responsible for keeping the integrity of the data, or keeping the integrity of the system, because the entire system is distributed, so we will not have any point of trust. So this is the case where we can use blockchain. Then it comes when we need a use when we are in a scenario where there is a multi-organizational data storage with automated access control. Now think about a supply chain, or think about automotive manufacturing unit. Automotive manufacturing process requires multi-organizational effort. When a car is built, it's not built by just one company. It's built by multiple companies. The car manufacturer, they source each and every materials from different ancillary companies, and those ancillaries they supply those materials, they come. So there needs to be a lot of data to be shared, because based on the prime manufacturer, that automotive manufacturers, there needs to be quality control for each and every material there or parts they are sourcing, and there has to be a process which should follow their guidelines. So although there is a different organizational process involved, there has to be some point where checks needs to be done, and everything should conform with a single law of or maybe a set of rules. So there we can use blockchain. Why and how? Because when the multiple organization will come in one place, like all the ancillaries will be providing the materials or tools or the parts to the buyer, the car manufacturer, they can use the blockchain, which blockchain can execute the smart contracts to validate the data, whether the quality has been checked. So for different part or different products, I mean, sorry, the materials. Say, let's say about the steering wheels, maybe the engine, maybe the gearbox. So for different part, there could be a different safety norm, different specification, different quality control checks. So all these independent things can be applied to blockchain using smart contract, and when the data will be passing through blockchain, it will be automatically validated. So entire process will be completely automated, completely secure, transparent, and it can be completely lot of time saving, and the entire process will be so structured. And like we are very used to, which will talk, I mean, knowing about blockchain, when it comes to blockchain, that we always think about these cryptocurrencies and this kind of blockchain. But there are different kind of blockchains, which we'll talk eventually later on. That where there is private blockchain. I mean, in cryptocurrency, we are used to see the public blockchains, like it's all open and everyone can participate. You can just download the node code, and you can run the node, and you will be the part of the blockchain network. But there is also private blockchain, where there will be a certifying authority, CA, what you call CA, and using that certificates only a node can participate. And also based on CS configuration, the visibility of data can be controlled as well. And not only the CS certifying authorities configuration, Also, we can write smart contracts which can control the visibility of the data or the access control of the data. So if this kind of structure is needed where the multi-organization participation is there, and we need to control the data, we need to manage the visibility of the data, access of the data, yet we have to keep entire system rolling automatically, and final goal is to keep the immutable data which we can check historically and we can validate it. Then this is a good use case, and this is that is the right point to use blockchain. And another point is when data transparency is needed. Data transparency is needed in many points. I mean, if you think very closely and very process all these governance and social sectors, then you will see most of the cases we need data transparency. So imagine all this in social sector, all these NGOs are working for different causes, and we are donating to them. So the transparency is very much needed there. We need to see that how much they have received, how much they have spent. So blockchain can have all this data, and in blockchain, in public blockchain, like we can see in any cryptocurrency, that you can just go to the blockchain explorer and you can explore the entire blockchain, or you can download it on your computer and you can go through block by block and you can see what the transaction has happened. So data transfer, when data transparency is needed, then no other data storage solution can give any better solution than blockchain, because the blockchain will be wide open, it will be completely transparent. You, me, anyone can download the blockchain and check it, and if they can go through it without breaching anyone's privacy, because even the addresses, wallets, or everything is hashed. So there is no particular user data over there. Even the data we store in many blockchain, we store multiple data. Not only even if you consider the cryptocurrencies, not all the cryptocurrency blockchains only use the only transactional data, that is transaction in and out. Many blockchain also use messages and other data as well. So all those data can also be encrypted and can be stored in a very encrypted way, which cannot be retrieved by just looking through the blockchain. So you need to have the keys to decrypt the data. So, but it can give you the complete transparency that how the process flowed, how the money came in, how the money went out, or even if it's not money, if it's something else, then you can see the take the overview, entire overview how it happened without knowing the personal details or small private data which you don't need to be when you should not be having that data. Yet the entire data will be unchanged because you cannot emit. So when the transparency is needed or any of these four condition matches, then it is a very good use case of blockchain. But this is not the only cases when we should be using blockchain, because sorry because there are a few more, but these are the primary point where which makes your or our one technological solution very good fit for blockchain. So now we will jump into the use cases of blockchain. First and foremost, of course, we cannot bypass fintech, because fintech is the basically industry which created all the buzz about blockchain. I don't want to go into cryptocurrency way because it's all known to everyone. It has been all started with Bitcoin, and then it came along this way. It is good that cryptocurrency started like that, and cryptocurrency started its journey to be alternate. The alternate to the money, but like now it's a good investment tool, because our monetary system has come along a long time, so it will take a while to change how the money functions too. But beside that thing, the fintech, the other part, like banking system, like investment system, insurance system, so all these industries also developing very good blockchain-based system, because the in finance system, in current days finance system, if you look very closely, they are very inefficient, because the inter organizational communication and inter organizational data delivery is so primitive that it takes long time to validate it. Because between the if you think about the swift transaction, a swift transaction from Europe to India takes somewhere around 4 to 7 days. Why it takes so much? Because when it comes to a area of banks, the data needs to be validated, and the validation of the data is not that secure. So it takes time to validate the data, because again we are going back to the trustless system, because uh, this data is not coming through a route which is where every node is trustless. Rather, every node is a trust-based system, a centralized system. So once and when our data is coming from one centralized system to another centralized system, the recipient system needs to validate the data thoroughly without taking the data without any verification, because the data may get tampered when it's transferring from that centralized system to another centralized system, because centralized system always keeps a door open for any kind of data manipulation. So when blockchain is used, then the entire transaction, even no matter how many points it touches, even if it when I'm transacting a data, say I'm point A and I'm sending the money to point B in US. So it can be direct. Even if it doesn't go direct, if it touches 4 more points, still it would be much faster. Still it can be done within a few minutes or maybe maximum an hour, because when our data going from my point to next point and that point to next point, then every point doesn't need to validate the data, complete data, because by default, when blockchain is accepting the data and when the blockchain participating nodes are distributed among within different parameters, if uh, all the nodes are acquired by a single organization, then it's a different story. I mean, we have to think how I mean the distribution of the blockchain. Distribution of the blockchain doesn't always mean it's a different computers only. If organization A owns the entire network of a blockchain, assume one blockchain network, say let's call that blockchain network as X. So X blockchain network is run by organization A, where there is a 10 participating nodes. All the nodes are owned by organization A. Then it's not a proper blockchain setup, because anyway it looks like blockchain, I mean decentralized network, but it's a centralized because it is centrally controlled by organization A. Now they can run any algorithmic program which can rewrite the entire blockchain of all 10 computers. But where the blockchain powers, when in fintech industry, let's go back to the banking system again. If all the banks participate around the world, and when we transact money and it touches 4 more points, the all transaction will be validated by all the banks around the world, because they are having, even each bank is having one participating node, there will be a wide variety of nodes. So it would be very hard to imagine that all the banks around the world will come into a general consensus to tamper the data. So that's how blockchain gives us the power. The more diversification it is, the more chances that the data will be immutable. Next, come to after fintech, the most important part is supply chain and logistics, of course. I mean, if you take the broader aspect, then logistics also part of supply chain. And in logistic part, the shipment companies have made really good progress on that. I mean, most of the shipping companies are using blockchain for that matter. And this blockchain has saved shipping companies like Maersk or other big shipping companies to save a lot. Uh, Also, the airports, they are also using a lot of airports are using blockchain to uh, tag the luggages they are handling. And if you take the supply chain as a whole, I mean the entire industry where the logistics, warehousing, and other parts are involved, then blockchain is the one of the best use case industry is the supply chain, because when it comes to warehousing, in normal process the warehousing is a nightmare, and it's a nightmare for technologies to build the perfect solution where it is a zero error warehousing, because there will be always mismatch. And when there will be some mismatch, maybe not the data side, maybe the data is correct, uh, but the physically it would be difficult. Then in a centralized system, it would be very difficult to get the data. And of course, it would be even more difficult if someone system admin or super admin having the access to the database, and if something goes and which can fire to him and he try to change it, and that if super admin changes the data, then it gets even more difficult. So supply chain, because and supply chain is even more use cases, because we already talked about multi-organizational setup, right? So if you think my supply chain as a whole, then you can see that a good setups are supply chain incorporates multiple organizations and from different industry, like a logistic company, a warehousing company, manufacturer, a retailer. So all different kind of industry, I mean businesses, different organization, they all come together, and the product flows from one side to another side, where we need the data transparency, we need how it's happening, and we need also automation. So the more automation will be involved in it, the more better uh, result we'll get. So supply chain comes the next. Then comes governance. The governance is very important, because governance need automation, governance need transparency, governance also need immutability. One example I have already given, the land. If you see, even the land scenario in India is very much corrupted one, uh, should I say. And there's a big scope, because the transparency, lack of transparency right now, the data transparency is not there, the counterfeiting is very much possible, and there's a very less checks about against counterfeit documents and all. And also, if you go beyond the land, other governance like fund allocation, giving the citizen benefit to the citizens, everywhere you can see there's a lots of loopholes, there's a lots of gaps where the data can drift through. So all these things makes a good potential use case for blockchain. And government, all the governments can be immensely get benefited out of uh, blockchain. Then comes agriculture. Agriculture is a difficult kind of application. I mean, if we only focus on blockchain, maybe you won't find much. I mean, there is benefit definitely, but if we think only blockchain, then blockchain doesn't get that much benefit. I mean, agriculture as a whole won't get benefited that much with blockchain. But if you combine few more emerging technologies like blockchain, if you integrate it with AI and ML, if you integrate it with IoT, then all this technology becomes indispensable. And with that, the entire agriculture can reach a height which can never be reached, and which never be imagined even. Because all this technology together gives so much power to the agriculture, then it can mitigate so much problems currently agricultural system is facing. And the agricultural system, the problem the agricultural system is facing current today is not limited to any geographic area, like it's India's problem or Africa's problem or Latin America's problem. More or less over the globe, there's a few problems which agricultural industries are facing. Even the industrial agricultural sector is having those issues. which basically naturally those developing nations are trying to already trying hard to mitigate with AI, ML, and IoT, and also blockchain is coming in many ways. Then comes education, and education. This is one good use case, and probably you all know. I mean, we know so many fake doctors. So many government employees who made a fake certificate 30 years back, and they got employed, and after 30 years or 20 years, they're getting caught and they're thrown into jail or whatever it is. We read this news in Indian newspaper, I think every year, at least once or twice. So, education, and again, it comes to the data immutability, transparency, and when a company is recruiting a person, how much this company is spending to validate the background of that company. I mean, sorry, that candidate. They are validating the educational degree all over again. I mean, the same checks are going over and over again. Every time an employee is switching the company, the same checks are going through over and over again. And because there is no immutable data, there is no one source where the organization can put on trust. I mean, basically, it's a trusted system. So, education is having enormous potentiality within that. And if it implemented from the very basic level, from the elementary level, then the entire system currently we are standing on to validating the users' data, like educational data, qualification, experience, anything, it can be mitigated. It can be mitigated, and it will not only save the, it will not only save the money, it will save the time as well. It's costing a lot of money to the companies. Even if someone is going for the foreign study, they need certificate validation. I know a few of my friends did. I mean, it takes approximately 1 month or so time. So it can save all that. And healthcare. Healthcare, of course. I mean, the example I have given so far, it fits the same for the blockchain. Sorry, healthcare, because healthcare is suffering from the same problems in some degree. So healthcare is one use case where blockchain can empower the industry altogether. Next, we are going to artificial intelligence and machine learning. So, in artificial intelligence and machine learning, also, we'll be touching the few things in very brief level, and we'll be sketching surface. So, first thing we'll see what is AI and ML, and second we'll see the different subsets of AI, and then we'll see what is the machine learning and its benefit, and then we'll see why we should use AI and ML, which is naturally a valid question, and we'll end up with use cases. I'll try to make it as short as possible. Probably we're running out of time. So what is AI and ML? AI is artificial intelligence. So let me read it through, then maybe we can, and probably most of you already know. So artificial intelligence is intelligence demonstrated by machines, unlike the natural intelligence displayed by human or animals, which involves consciousness and emotionality. So basically, the statement tells everything. So we need the machine, computers, or a similar kind of computing system provides intelligence without any emotionality and consciousness. That is artificial intelligence. Which is good or bad is a different aspect, because recent studies suggest that even general AI scientists and everything, everyone is trying to put some consciousness and emotionality towards the intelligence, because these things not only enhances the intelligence, it also improves the learning process of because learning is one more integral part of artificial intelligence. If we see, I mean, we recent days we say that AI and ML is a emerging technology. But if we think, if you go down a little bit down the history line, then you'll see that artificial intelligence is not emerging technologies. It actually emerged long before World War, long before World War One even. Uh, of course, that time there was no computers, so artificial intelligence was mostly limited within the statistics and mathematics, and which is to be done by in pen and paper. But still, that is a kind of intelligence which doesn't involve the human or natural intelligence. But how we are talking about this AI and ML as emerging technology, how it rose to this level in last 2 decades, because we, even if you go back say 30 years, we used to have video games which used to use artificial intelligence. That time artificial intelligence was always like algorithmic intelligence, like what you used to have, what I was talking about before World War, or even that area. That was based on few mathematical algorithm, few statistical algorithm, data sampling, and that kind of uh, formulas. But later point when the machine learning came, when we started teaching the machine, when we made a computer act like a human, where it starts to learn like a human child starts to learn from zero, it starts to learn how to walk, how to stand. It goes through as our brain goes through a reward and reward based system. When it do something, when it does something properly, it gets rewarded. When it does bad, it gets penalized. And that's how our human brain and most of the other animals brain works. But our human brain works mostly because it's almost not hardware, like unlike other animal brains, which is mostly hardware. So our AI system also was previously like that, hardware. We used to have some algorithmic basic structured code, and everything used to go through that, and which used to pass those conditions used to go through. Definitely, it used to be some intelligence, but not as intelligent as organically intelligent like machine learning is. So, what is machine learning? Machine learning is a study of computer algorithm that improves automatically through experience and by the use of data. Basically, use of data, when we say use of data, that is the data it process. It could be any data. Like when we start first, even if you take the example of human brain, when we start to walk, when a kid, a baby first take the first step, the taking the first step, lifting up the leg to putting it down to the ground. This is a data how it brain receives, and if it can plant properly, then brain takes it as reward because it is a success. If it fails, that is not a reward, that is a penalty. So that's how we learn, and that's exactly what machine learning is. A reward-based system where machine try to do something. If the result is positive, it's a reward, it gets a point, and if the result is negative, it gets penalized, it reduces the point. So different subset of AI and ML. First is general AI. General AI is what we call, we see the data science and everything. These are general AI, where it's based on our general intelligence and uh, stuff we need, mostly processing the different kind of data. Second comes computer vision. This is probably the most important subset of AI in modern days, because whatever the improvement or whatever the sci-fi scientific sci-fi kind of technology we are seeing around us today, without computer vision, it wouldn't be possible to take. If we take from medical diagnostic to self-driving car, without computer vision, nothing would be possible. So this is probably the one of the most important uh, subset of AI. And then comes natural language processing. Natural language processing is how AI processes the human language. When we speak something, uh, we speak in our language. Sorry, and how AI process that language is called natural language processing. You can see the very you can identify NLP, which is natural language processing, with CD or Google or Alexa. Basically, they are the very high level of natural language processing. But if you uh, if you go by, but natural language processing always definitely does not mean that the voice synthesis, like I'm speaking something and the AI is listening something. Anyway, that is a different technology which converts my voice into text. So NLP is always text based. So it a voice synthesis program just takes my voice. So it's a speech to text technology, speech to text. That is, take the speech, converts it into text, and then NLP text. Maybe some of you already use Grammarly. Grammarly is a natural language processing program. Probably you have know the GPT. GPT also text-based, GPT-3. So basically, these are natural language processing. It's a text how human are speaking, the how the emotions are expressed through a sentence. How if we put up certain word, if it meaning anger, or if it meaning joy, or if it meaning sadness, maybe same word meanings meaning this expressed all three expression, but based on the structure we make in a sentence, defines the expression or defines the emotions. That is what natural language process NLP is, to read out the entire text, to read out the entire sentence, or maybe read out the entire paragraph, build out the context, and then process and try to make out the um, sense out of it. What is trying to say, what the speaker or whoever is telling what is trying to say. Then comes deep learning. Deep learning is basically, is making the neural networks. Basically, in machine learning, we try to mimic the human brain system, where we have synapses and all. So we make a neural network system, but artificial neural network. And we just want to pass through the data through neural network, how it happens in our brain. And deep learning basically does the same thing. There's a different kind of algorithm in machine learning, how we can learn, like back propagation and this kind of. I mean, I don't want to get into much deep into this technical discussion, because then it will be a never-ending process. So deep learning is a process which we try to mimic our neural network system. We build an artificial neural network and we learn, pass the data through it, and we learn the way I explained, that rewarding and penalizing system. Now we'll discuss what is machine learning and its benefit. Basically, machine learning mimics the biological neural system that we are having, the humans are having mostly. Because we don't try to mimic animal brain system much, because as I told earlier, that most of the animal brains are hardwired. So basically, they're born with things. So with their gene, their DNA passes most of the data in their brain, and they go by the instinct. But in case of human, we that's why we take longer time. Sorry, excuse me. Drink some water. Sorry. In human brain, we come very less hardware. So we learn from our experiences, learn from our surroundings. That's why you can see when a calf is born, or a zebra calf is born, or any, they take hardly 1 hour or 2 hours to stand up, and then within few hours you can see them running around the field. But in a human child, it takes at least 7 to 8 months just to stand. Then a human child takes at least 4 to 5 months just to sit, because nothing is hardwired. We learn everything. So if you take, I mean, if you take a kid from any environment, let's say, we have a very common concept that the kids from slum is very dumb, or kids from a very remote village is not so smart. You pick any newborn baby from remote village and you put in a very good, all well-funded urban system, you'll see that that human child is thriving. So basically, it's not hardware, and exactly what that we try to mimic in machine learning. That we provide a very basic set of algorithm. That algorithm enable computer to learn through reward-based system. And we keep training the data. We keep providing the data. We train the model, and model keeps learning through the reward and penalty system. Second is the result of ML is more organic, hence the outcome is more compatible with human requirement. It's pretty much understandable because we are training the machine learning models like very organic way, how our brain functions. So naturally, the learning will be very much intelligent like us, and naturally, the outcome will be very much aligned with our outcome. But since AI and ML can take large set of data, like if you think about human brain, we always average out because we cannot process all the data. So throughout our life, when even if our profession, if you take a doctor, if a doctor takes a kind of patient which is having a particular symptom, and if he takes the another patient with same symptom, he'll not remember both the patient's symptom, and so his brain will do merge it together. It's just mean. They combine the data, sum the data, half it will take the average and store the average. So in our mind, we always have the average of data. But the problem is, if you know statistics, that mean data is not always the correct data. That's why when in human behavior, you can see lots of error because we always take the mean data. Our brain always takes the mean data because our brain cannot process all the data. But this computation or memory bottlenecks we don't have with machines. If we provide enough power or enough processor or memory power, then a machine can train enormously. I mean, it cannot. It cannot be matched with any human because the abundance of the computational power. Third is, as ML takes experience in account, it enables AI to achieve more human-like performances. Exactly what we spoke so far. That it takes experiences. So if it fails, it takes it as a penalty. So it always embraces with the rewards. That is the success. So why AI and ML? As we can see, in most of the areas, AIs are replacing humans, and it is in many studies it is suggested that by 2045, every human will be jobless. Jobless in the term of what job we are currently doing, not that will be out of job or out of money or so. It meaning whatever the job we are doing, everything will be replaced by AI. But it's a radical change to our human society. So why do we need that basically? Because if you think, you'll see that most of the things we are doing is very repetitive process. Even I don't know how many of you from a technical background, even we who are very technical background, doing programming, coding every day, writing AI things and logics, algorithms, training models, whatever we are doing, no matter how much we think we are doing unique stuff, we are not doing unique. We are repeating everything. We are not going beyond something. Even if we are writing a big model for AI or our machine learning, still we are writing in Python. We are still bind by few rules. So we are repeating the same rules over and over again. We are applying statistical formulas. We are applying this formula, that formula. Basically, so this repetition is not needed. Our human brain is much more capable of than doing all these things. If you think of driving from going one place to another place, if everything kept correctly, then we don't need a human brain to do this thing. A simple computer can easily do this thing. That's why we need AI, because nowadays the work we are doing, the human society, in human society, each and every human are doing 90% jobs. This is a waste of human resources. We can do a lot better things. We can do a lot better things than what we are doing currently. So we are basically doing a very repetitive thing. which doesn't need our brain to work too much on, which a simple computer can do it. That's why we need it. So it automate the repetitive process. Secondly, AI and ML, it can process very large amount of data. I mean, if we give up 10 terabytes of data, it can crunch through and it can give a result in 1 day, 24 hours, or maximum 48 hours if you don't provide enough computing power. But if we give 4 terabytes of data to any human brain, it will explode. So naturally, when we need high accuracy analytics or any kind of with a large amount of data, then definitely AIML is much better solution, and it can easily replace human. It can give, I shouldn't say replace, it can give much better result than human brain or any human, because there the power is. And third is large data set processing enables more efficient result than human counterpart, because we cannot process so much of data. Like if you take an example, if you take a mobile number, 10-digit mobile number, if you read it through 10 digits at a time, you cannot remember, because our short-term memory is very small. So if you take the same number, you put a dash in between three numbers, you can remember the same 10 digits number easily, because then you will be breaking into parts, and your short-term memory will be storing in different memory. So a full number your short-term memory cannot allocate, but a small memory or a small part can be allocated in different short-term memory, and you can remember the entire number. But computer doesn't have that limitation. Computer is limited by the a 64-bit system is limited to 64-bit. 64-bit is a large number. So computer in a way is much capable to handle more data than a human brain is capable of. Second, with the same data, the more you data put in, the more accuracy comes in predictiveness. That's why you see, I mean, if you are having, a bit age of 40 or around, then probably in 20 years back, you used to see that whatever the weather department says, it happens exactly opposite. Why? Because they had so less data. So whenever they used to do the statistical analysis, they used to have very wrong data, because their data set was so small. Nowadays, but they kept getting the data and they kept analyzing. Nowadays, we have terabytes and terabytes of weather data. Now you go to weather.com or AccuWeather, you will see almost accurate. Whenever they are saying it will be raining around 5 p.m., maybe it's not 5 p.m., 5:30, it's raining. You pass it 10 more years, and you'll see when they can predict it by the minutes, when it will rain, when the cloud will come, or when it will not, because of the data. In our universe, everything happens in a pattern. You just need to have enough data to analyze that pattern, and you can predict anything. You can predict anything if you have enough data. And so, since machine can crunch to a large amount of data, it can predict very easily. It can easily detect, if we have the MRIs of 10,000 MRIs, it can pass through 10,000 MRIs, it can find the similarities. If a human passes through 10,000 MRIs, after even 100 MRIs, the human brain won't remember what was the first MRI looked like. So this is the limitation of human brain. Sorry. The fifth is, can improve performance of software or hardware manifold with intelligence. It's common. I mean, when the hardware or software works bluntly without implementing the intelligence, then it works a different way. When it comes with more intelligence, it works a much better way. What you can easily understand with YouTube. I mean, you see, when YouTube was first started, it used to give some, unbelievable suggestions. I mean, it didn't even used to give any suggestion. It used to give some most popular videos. But nowadays, it curates the video according to your likes. Even if you noticed or not, if you have YouTube account in your computer, in your TV, if you watch TV, in your TV account, they'll be giving the most of the content which you watch more in TV, not in computer. When you sit in computer, they'll be giving you more content which is which you watch in computer. So basically, This intelligence it improves the performance of the software and hardware itself. If we rely on the hardware, sorry. So, use cases of AIML. Self-driving vehicle, a classic example of AIML, which almost covers a lots of subset of AI and other technologies like it takes into account of computer vision, it takes into account of sensor fusion, it takes into account of other statistical analysis. Uh, so basically, it's a very vast. I mean, it's a implementation of multiple technologies in a very vast and very high tech and top notch way. So definitely it's the number one. Second is manufacturing. Manufacturing is definitely done. Manufacturing also incorporates computer vision. It uses robots, which is having eyes, aka cameras, and naturally this manufacturing units. All these things are mostly run by robots, and those robots are sorry not remotely operated by humans, but they are autonomous robots. So this autonomy comes from the AI system. Then comes the commerce. You know how Amazon works. I mean, Amazon's entire logistics system, their entire supply chain to their own e-commerce platform. Everything is backed by backed by artificial intelligence. Without AI and ML, Amazon would be a dead fish on the pond. So not only Amazon, I have few of my friends who are working in Swiggy. They have a very good and very large AI division. They are constantly updating the fraud detection system because it's a very common scenario for frauding this food delivery apps from both from customer side, from restaurant side, from the delivery agent side. I mean, there are people who try to cheat other. So these efforts they are continuously mitigating with AI. Every fortnightly they change their models. So because I mean, this is about Swiggy only. I don't know about Zomato or other. So for Swiggy, they have seen the trend that every fortnightly the fraud pattern changes. So every fortnightly they train the model. They keep the old model, they train a new model, they treat that new model, and that's how they keep going. And so this is one part of e-commerce. If you go by any e-commerce system, if it's large, if it's having especially the aggregators, then AI has to be there. Without AI, it's not possible. Even when you are using Ola, I mean, if Ola is passing through your toll, then your charge will be different. If it's not passing through a toll, your charge will be lesser. How is it getting detected? It's getting detected by the AI because CV is learning the map and then it's detecting and is building out the bill. Also based on a lot of other factors like how slow the vehicle moved, how much it's stuck into traffic and all this stuff. But anyway, the entire data is being processed by AI system and then fed it back to the user interface or whatever the user system is having. Healthcare is a big buzz. I mean, I don't need to speak too much about it because probably most of you already know. And even if I start to speak, it would be too much of work. I mean, from Google's prediction of when a people may die to the German's company, I forgot the name, who is trying to detect whether you are having cancer. I mean, when a person is having a cancer or not by taking the snapshot of face pigmentation. So healthcare segment, from prediction to detection, thousands of startups are working on that, and thousands of startups are working. Thousands of startups are doing well, very well, and we have seen so many predictive systems, and those predictive systems are working so well just because of AI. And AI means that because of deep learning. Without deep learning, it wouldn't be possible. And Google's division DeepMind has already been, basically they work on general AI. They don't work on any specific stream of AI. But yeah, the general AI, when they do something, finish their result in general AI, then it's taken to a specific branch. So last deep learning's of research has been taken by Google for predictiveness of diabetes. So lots of work is going on, and it's one of the prime sector where the AI is finding good application, and what is basically changing the society altogether. Social sectors also having a lot of lots of mm, sorry, uh, lots of improvements and applications using AI and ML. One I can see, maybe you are already aware of. In India, we have the Clean Ganga Mission C Ganga, that is Mission Clean Ganga, under NNCT. They are using a lot of data, which is basically led by the IIT Kanpur. They are taking all the data from Ganges. I mean, it's a sensor data, it's a visual data like photographs, drone videos, and all. They are passing through sensor data. They are passing through different kind of generalized system. They are passing the videos and photos through computer vision system, and and they have been very successful, to making up the policy which can make cleaner government. And this is only one. I mean, there are lots and lots of sectors. I mean, even in the central government is their Jal Shakti department is working relentlessly using AI to improve the water quality of our country. So basically, there are lots of social sectors and governance which are getting benefited using AI, and which is having enormous potentiality. Because if you see, I mean, we have so much large society, and we have so many stuffs going around us, so we have lots of scope still to do. I mean, using AI, we have so many. And seven is everywhere. I wrote everywhere because uh, it's in few studies is saying that by 2028, all the businesses in the world will be using AI actively or passively. So you can understand the reach or the importance of AI. If you are already into AI, probably you understand that it won't take 2028, because by now almost 80% businesses are using AI in one way or another. I mean, if you are using Gmail for your business, you are already using AI. Not actively but passively. So in one way or another, if you are an Amazon seller, then already you are using AI. So basically, each and every business will use AI in actively or passively, and the scope of AI is everywhere, because AI is having the potential to replace what we are doing today as human. So basically, everywhere we are. So everywhere AI can be, and AI can free ourselves from doing all these nitty gritties and focus ourselves doing something really good. I mean, if you are more from the science stream, if you have been in physics, you already know that is a great topic of research in physics, that what we are. I mean, are we in a universe? Are we alone? Even we don't know. I mean, there's a theory that we could be a simulation. We could be like a video game. We could not be even real. So lots of these are really answers. These answers can't be found by AI. At least not the AI we know currently. So these AI and ML cannot find these answers, which we need to find. There are so many things we can do beyond this planet, which AI can't do, which we need to do. So the lot better scopes are in front of us. In the horizon, there's a lot of things to do for humans, as we can use our intelligence, which is much greater than AI ML, because we have lots of emotions, we have lots of things beyond the intelligence. which AI don't have. So that's it. Thank you so much for being in this webinar and for listening to it. And I think there's some question and answer session with that. Thank you so much. And I'll stop sharing my screen right now. Okay, so are you taking question answer or how will you be doing it?
Hello, Bhaskar sir.
Yes.
Audible, sir.
Yeah, yeah.
Sir, can you throw some light on IoT also, sir? Uh,
Yeah. Okay, IoT basically, as it says, Internet of Things. Basically, if you IoT basically comes into two different part. One is industrial IoT, one is home IoT. So industrial IoT is a process, automation process, which enables the industrial part to work. And home IoT is basically non-industrial part to make the various device to work. So what is Internet of Things? Internet of Things are different kind of devices which are connected through internet and can talk to each other. So for example, let's take one smart AC. For example, how IoT works. If anyone of you don't know, so you can set up your AC that when you start before from your office, your from office to home maybe takes 15 minutes. So when you reach home, your home will be cool enough so you can just get in. So your AC will be connected to the internet, your phone is connected to the internet, and your phone is connected to the GPS. So when you leave the office premises by GPS location, it automatically triggers your AC to turn on. Your AC turns on, you get back to your home from office, and you get a cold home. Similarly, you can do, we can do a lot of things like perimeter blocking, is in case suppose your door is having a IoT door lock, then in case if you forget, if you forget to lock it, maybe it's a biometric lock which is having the basic lock, but you have to use the biometric to fully lock it. You can configure it the perimeter locking. So when you leave your house in a certain area, you go out of the perimeter, your door automatically gets locked. Your phone is having internet and GPS, so it just works the same way. And also, if you see the industrial IoT, like in US, one of the Amazon warehouse completely uses IoT. Like when a particular robot approaches a particular rack, the racks also semi robotic. So it opens up and the robot hand it collects the items, it brings in, and then when the robot leaves, the rack closes in automatically. So this is the IoT, because the two devices are talking to each other with through the internet, and they work collaborate like we do. Multiple humans do work, perform different tasks collaboratively. So this is what IoT is. Now IoT basically, IoT is a conjunction of multiple technologies. So if we have to use IoT uh, very accurately, we have to use definitely AI, because the more we use AI, more we put intelligence to the behavior of a machine, the more efficient of the outcome will come, and the coordination between two machines will be much more. If you think that if you take that robot Spot from Boston Dynamic. They have released it probably a few months back. So in demonstration, they have shown that the two spots have worked together collaboratively how to rescue a person or rescue something. I exactly don't remember right now, but that is also a classic example of IoT, because two robots are basically collaborating with each other. But at the same time, this collaboration becomes so effortless and so efficient because of this AI. And also, when we talk about IoT, we have to have a focus on the higher degree of internet connectivity. There is a blockchain. I mean, not blockchain exactly, as a DLT, a distributed ledger. Probably you already know IOTA. They are having a cryptocurrency. So IOTA is basically focused on microtransactions, which can be used by IoT devices, and to do that. Basically, that focus is basically on IoT. That's why the DLT is named as IOTA. So when that comes, it would be. I mean, if you take that DLT in place, then it becomes more powerful. And imagine in a society where each car, each and every car is autonomous vehicle, and then an accident happens. Now, what will happen? I mean, when you can imagine when the entire society will be having the 100% autonomous car, that time AI will be very much developed, and that time it could be very much possible that AI will start to manipulating the truth. Maybe AI will start declining. I mean, AI will behave like us, and it will talk. I mean, if responsible AI will decline from taking the responsibility of accident. That time the DLT will come in place, which will ensure with the immutable data that what exactly happened. And even the mixed condition, it's even more viable, where few of the cars are autonomous, few of the cars are not. Then it would be very much important to know exactly what happened if something happens on the road. So basically, IoT is having enormous potentiality, but you have to understand that IoT, unlike the other technology, like um, a blockchain or AIML, even if you take the XR, that extended reality we talk about, AR, VR, MR, those kind of technology. These are standalone technologies. These are technology, but IoT is basically combination of technology. It is basically a technology which uh, powers your existing things, or maybe it powers you to develop things, which can be the gadgets we are using every day, or which is a production assembly machine, or anything. But basically, IoT is more focused towards the hardware part, because in IoT, basically is a communication between two computers. So when you are making IoT, yeah, hardware is very much required. I mean, without hardware, I mean, these things, I mean, the technology, rest of the emerging technology we are talking about, it doesn't rely on a particular hardware. I mean, definitely, if you consider XR, extended reality, definitely you need something. But in XR, if you think about AR, only the AR part, then or even mixed reality. Then sometimes you can get away with just mobile or tablet. But for IoT, I mean, it's more this technology is more focused towards hardware implementation, and it's having its own scope with assembling other technologies, because if you don't put in other technologies, if you don't tether other technologies, then IoT doesn't form at all. Uh, Anything else?
Uh, Thank you, sir. Thank you, Bhaskar sir. Sir, I have a question,
Okay.
sir.
Yeah. You
Uh,
can call me without sir. Bhaskar will be nice.
okay, no issues, Bhaskar. So, what,
Okay.
Bhaskar, what our startup is basically focusing on STEM education and 21st century skills for kids and students. So, I just want to know and understand this part as to how much it is important for the students and the kids in their schooling that they come across all these new technologies which are coming up. So how do you see that this technology is getting itself involved in studies for the students and kids for say standard 1 to 10 or 12? Because in the NEP, a national education policy, already coding has been included. Thereafter, AI is also included for standard 9 students, and now they are talking about data science to be included in the curriculum. So how do you see that these things are evolving in the near future?
Yeah, it will be involving in near future definitely. But I think. mm uh, from my perspective, the approach should be a little bit different because you see, I mean, if anyone comes from technical background, you probably already know that knowing coding is not a big thing. I mean, because whoever in coding or programming or software engineering career, you have learned probably 10 or 15 different languages. So it doesn't really matter whether you know programming or not. The more important, and even when we started learning programming, that day the programming and today's programming is completely different. It's completely different scenario. So it should be more focused on the basic core thing. If you think blockchain, uh, blockchain is a very niche technology and it's completely based on cryptography. Cryptography is a very high end mathematical problems. It's not nothing to do with programming, and programming is a very a set of set of instruction. Is programming is like if you know English, is learning French. So it's basically a language how you can instruct a computer to function, but that doesn't make the algorithms. Algorithms makes the fundamental knowledge. Cryptography has been used for, I mean, centuries. I mean, previously in Europe, they used to cryptograph the information within the paintings and all. They used to cipher it. So ciphering is a very old thing, and it's all based on the mathematics. So a student who knows Python, I mean, can write a nice web page in Python, can't make a single good smart contract or anything any I mean even may write smart contract, but any good blockchain core blockchain stuff, because if that student doesn't have the mathematical foundation, even if you go to AI or ML, we are trying to mimic how our human brain works, and in our human brain none of our programming language is safe. I mean, when a kid is born, his brain is not, or her brain is not coded in Python or C or Rust or any of the language, right? So our brain works in mathematics. We are trying to mimic our brain, so naturally it all boils down to the mathematics. So if student comes, I mean, naturally it's a education policy, and the policies depends on many things. Not necessarily in any country. It not necessarily mean on achieving the excellence. Policy based on many things, but the foundation thing. I think there is no student in here, but if the parents are there, and if you really want to shine, anyway, if we, any of us, wants our kid to go there and make some change and make some mark, then definitely, if you want technology to be that, to be the vehicle, then definitely sooner or later they need to learn the programming. But uh, the current days, whatever you see current days has been developed. Very few of them, started programming, and very professional level programming at grade 6, 7, 8, 9, 10, even 11, 12. Most of them have started in their college level. In their college level means, if we talk about the developed nation, college level means their college means the postgraduate. That is the after bachelor degree. Not postgraduate, basically graduate. That is after bachelor degree. So in that level, they started coding, and with that one, we got what we are getting right now. So it's not necessarily, but what all of these scientists, you take any good computer engineer or computer scientist or data scientist or whoever, whatever you call, they have very good foundation on statistics, mathematics. So the basic thing which will make you to program. Otherwise, knowing that language won't help you to make any great program. So fundamental knowledge should be there, and all these new upcoming technologies, they are fundamentally based on mathematics, statistics, or basically statistics is a subset of mathematics. So basically mathematics is all in foundation. If someone knows, is very strong at mathematics, they'll find, they can write code in maybe 2 months, if they don't know coding at all.
Thank you, sir. Thank you for your explanation.
Any question, other?
Am I audible? Bhaskar.
Yeah.
Yeah. Okay. Fine. Cool. I had some, I think, some speaker issue. I was trying to speak from quite a long time, but I think like nobody heard me. Okay. Uh, so any more questions from the participants out here? Okay. So I'm handing over to Sanjeev.
Hello, hi Bhaskar sir.
Hello, hello, Sanjay.
Yes, actually, I want to ask you how affordable this blockchain system or AI to a new startups who is not yet funded well. So, can new startup afford it to implement this system in the company?
Well, if you, it depends. If you want to build your own system, if you are trying something new, and suppose you want to, if you are trying to build a solution, I'm speaking about AI. Okay, if you are trying to build a system which doesn't have any available model in anywhere in public domain, and you are trying to do something, breakthrough, and then I think it would be very difficult for a startup to do it, because AI, specifically deep learning, is a very very expensive expensive endeavor. I mean, you have to hire a really high end machine to even if you take a cloud-based solution, still you have to pay a lot to train a model, and you have to keep training it. You have to get the data. So it depends on what kind of solution you are looking into. There are lots of AI solution. I mean, if you want to make a chatbot, for instance, so it will be very
Yes.
easy because for chatbot,
Yes.
lots of NLP APIs are already there. You don't even have to code for AI. You can just call the API, and API will do all the muscle work behind. But that is not exactly AI coding exactly, right? So if you want to build some AI solution by yourself, it would be very difficult. On the other hand, blockchain is not that resource intensive. So blockchain can be implemented very easily. I mean, you can take, say, you want to build up enterprise solution, say for example, supply chain, right? You got a client, you can take Ethereum. You don't have to take enterprise, or maybe you can go to a completely different way. Like you can go to Hyperledger. They have Fabric. They have Sawtooth. So you can pick any of the blockchain that suits your need. You implement it. You initially use your laptop only. Probably startup will be having 3 or 4 laptops. You install in laptops. You make your own network. You demo it. You make a POC, or maybe a pilot project, or whatever it is, and you can start serving it. I mean, blockchain is not that expensive at all, because you don't need to create your new blockchain unless you are trying to achieve something which none of the blockchain in existence can serve. Otherwise, creating a blockchain would be reinventing the wheel. It doesn't make, but for AI or deep learning is not the case. So for deep learning, you need some money.
Okay. Okay. Thank you.
Okay.
Thank you.
Okay, thank you, Sanjeev. Uh, so any other person who would like to? Okay, we have Siddharth. Yeah, Siddharth.
Yeah.
Bhaskar, I'll just add to what Sanjeev has told right now, and the answer which was given by you. I want to understand that I got a client recently who said that we want to implement blockchain technology for our for our company having 100 employees, and they were basically a supply chain management company
Mhm.
of PVC pipes and all this.
Okay.
So they got 100 employees. They got 10 warehouse in the entire northeast area.
Mhm.
So it's appropriate for us to implement that through blockchain technology, or we should create some kind of a web app based solution, not web app based solution. So you are saying that blockchain would be very better solution offering to these type of clients, right?
Exactly. I mean, see, you have to anyway have a web interface or app, because
Okay.
blockchain and AI is basically a backend technology. It doesn't have any interface, so you have to build some kind of interface anyway. But for the data storage, of course, if you use blockchain, I mean, for your particular case, it would be even much better if you use a particular blockchain along with IPFS. Then it would be even better solution for you.
Okay, so that can be done on the Ethereum itself, right? On the Ethereum platform.
Yes, that can be done on Ethereum platform, but for your need, I think Hyperledger suits much better than Ethereum.
Okay, so while implementing such kind of projects on
Mhm.
Hyperledger, so we have to pay something to Hyperledger, or we can directly create some kind of smart contracts therein.
No, see, you have to download. Hyperledger is offering 3 blockchains. For you, I think it would be much easier to use Sawtooth. Sawtooth basically interface with even JavaScript. So if you are having JavaScript programmer, they can write the smart contract. You have to download it. You have to make your own network. It's all open source. Hyperledger is all open source.
Okay, open
Yes.
source. So basically, on the open source, we create some smart contracts, and the solutions can be given to the company directly, right? The
No, I mean,
end consumer,
you can
right?
give the solution, but see, I mean, the Hyperledger is giving you the software, the code, not the network. So you have to build the
So,
network. But your company, I mean, if the client is having 100 warehouses, they won't have problem having one computer in each warehouse. That means potentially they'll be having 100 nodes. That means they'll be having a very strong blockchain network. So each computer can run.
so they need,
Mhm.
yes, Bhaskar. So they have 10 warehouse and 100
Okay.
employees. So they want to integrate all these things at one place. So that was the solution they were looking for. So while giving this solution, we should rely on blockchain, right?
Uh, I'm not understanding why they want to keep it in one place.
No, so they want to have a central control of everything. That is
Yes.
they are looking right.
So there are 10 warehouse can have 10 independent computers. I mean, which I'm pretty sure they're already having. So each computer can have a blockchain node which can run, and in central way they can run a certificate authority (CA), which will allow all these nodes to join in. So other than those, they are what they are allowing. Other than those nodes, no one can join their network and get the data, and they'll be having total control over their network. So no one else will be able to access it other than them.
Okay, Bhaskar, can I have your number so I can take
Yeah,
this details forward
sure,
also? I'll request sign-in team to have me access of yours also as a number.
sure. Sign in can give you
Yeah,
my number. They knows both
yeah.
my numbers.
No issues.
Thank you.
Thank you, Bhaskar.
Thank you, Siddharth. Like moving forward, so we are actually having around 28, sorry, 18 minutes more. Does anybody else have any questions for Bhaskar? No. Okay. So like Bhaskar, I think we'll just go ahead and
Yeah,
wrap this up
sure.
now. Okay.
Mhm.
Yeah. So first of all, like Bhaskar, thanks for coming and giving your time. It was a wonderful session. Uh, Lots of questions are there from multiple people. I definitely know that, but probably they'll go back and
Mhm.
maybe do some readings and then probably come back with more questions. And sign in will definitely be in touch with you if some people want to actually ask your questions or have a different session with you.
Mhm.
Okay. So first of all, so that's pretty much what or how we'll actually wrap it up today. So thanks everyone. Thanks for joining this particular program, and we'll send you a feedback form. Okay, after this meeting, do actually share your feedbacks with us and let us know what went well, what didn't go well. Okay, and we'll be really glad to have your feedback. Cool. Thank you very much, everyone.
Thank you, everyone. Thank you.
Thank you, Bhaskar.
Thank you.
Take care.
Bye bye.
Bye bye.